Right, good morning, Form 5. A short video looking at measuring curve lines on maps, but also considering directions, compass points, and bearings. All these things are related. And measuring is also related to the scale. So let's share screen. Again, the Geo-Hacks videos that I provided you are much better than what I can do. These videos are just to encourage those that struggle with maps to look a bit deeper and to realize that this is a very achievable paper. Okay, so last time we looked at measuring straight lines. This time we're going to look at measuring curve lines. Now, as you can see from the example here, we've got this red line, whatever that is, a road, you'll tell by the key. It's not straight. So we have to break it up into smaller sections. In order to do that, we can use a piece of paper, okay, to mark each point where it curves. Then we can add up the total length of the marks on the paper, and that's our measurement, which we can then convert into distance by using the scale, okay? Let me show you a bit more on this slide that I've created, okay? I'll just move myself a little bit. So first of all, I'm going to show us a curved line, but before we measure it, questions often come up to describe lines or rivers or roads and their direction and what they do on the map, usually starting at the top left-hand corner, moving across. You had this in your mocks. So what I've done here is I've put in a very useful compass with all the main directions, compass points you need to know, but also the associated angles and bearings, okay? And I've designed a question, find the river that crosses the map, describe the route of the river. Well, this thing I've drawn is supposed to be the river, okay? But listen to how I'm describing it, okay? The river X runs from the northwest corner of the map, okay? That starts here. And look, that's northwest. It runs from the northwest. It heads southeast. So it's starting in the northwest. It's now heading southeast. And you can see from here, it's heading southeast, okay, of a bearing near 135 degrees. So it starts in the northwest, but then it heads southeast until it meets the village X. So we're calling this village X, okay? And around village X, it curves. Okay, that's an important word. It curves. It curves towards the northeast. Okay, so we're starting in the northwest, we're running southeast, and then by this village, we're curving towards the northeast. Okay, as corroborated by this. Okay, and then I said it curves again. This is a railway bridge I've mocked up here until just after the railway, it should be just before the railway bridge, really. It curves again to the southeast. But notice how I'm using compass directions to describe the course of the river. I'm also mentioning that it curves. Which direction does it curve? Does it curve near any particular features like Village X or the railway crossing? This come up in your mocks. It's likely to come up again. You need to understand it. It's quite simple. You need to understand and be able to describe these 16 compass points. Okay. Now, in order to measure the line, I've used the same line, but what I've done is I've pretended, let's just pretend now that this is a village X and this is an intersection across a road or something, and it's asking you to measure the distance between the two, okay, of this road A. So I'm lining up my piece of paper. I'm marking that. I also mark on my piece of paper, but also I mark on the map. So I know the last point I marked. I rotate to get another straight bit of line in, marking on my paper, little strip of paper, but also marking on the map. So I know where I'm rotating from. Next one, record the distance, marking on the map and the paper. Twisting the paper round from your last mark to the next one where you can get straight line in, mark it, okay? And then you lay it out. You lay out the total marks you've got, and you use your ruler to add up the distance. And in this case, it's 23.5 centimeters. So we know the distance is 23.5 centimeters by doing that process. Okay. Now, if our map will only be a 1 in 25,000 or a 1 in 50,000. If our map is a 1 in 25,000, 1 in 25,000 means 1 cent equals 250 meters. So we would simply do 23.5 times 250. That equals 5,875 meters, or 5.875 kilometers. If it's the bigger scale, the 1 in 50,000, 1 centimeter represents 500 meters. So it'd be 23.5 times 500, which is 11,750 meters, or 11.5 kilometers. Okay, again, use Geo-Hacks, much better than I am doing this. Okay, finally, we're looking at bearings. So this is a 360-degree protractor, and I marked 2 points. Say this is point A, village X or whatever it is, village A, and it's asking you the bearing to this village B. Okay, now you line up your protractor and then you draw the line through, and we can see that it's heading southeast and it's probably towards the southeast around here. It looks like it's about 120 degrees, the bearing, okay? 120 degrees. Let's try another one, going around the other side. Let's call that town X. And this time we're drawing the line through. We know it's roughly heading in a kind of southwest, west-southwest direction, okay? And we're somewhere about 245 degrees, okay? If you can get one of these projectors, I'm still looking, but understand the relationship between the compass points, the 16 compass points you need, and the degrees, okay? Learn that well, it will make life a lot easier, okay? So that is today's video. Please use Geo-Hacks. Please look at the past papers I've given you. This is just to encourage you to keep going with this a little bit every day for paper 2. I had one of you come in today to sit with me, which was good. But you only get in, you only get out what you put in, guys. Okay, you take care and I'll speak soon. Bye.